Thank you for introduction. And so, I'm Junichi Yamaoka from Keio University. I'd like to introduce about our new fabrication method, BlowFab, which can produce this kind of hard and inflatable products. So we propose a new prototype method, BlowFab, which can create a 2.5 dimensional object in a short time by combining laser cutting and blow molding. The user can create hard prototypes by laser cutting, heating a seat, and injecting air. The user can create uneven texture and bend in any direction by cutting pattern on the surface. So in the fabrication field, nowadays many digital fabrication tools like 3D printer are appearing. But traditional fabrication, blow molding, is a manufacturing method used to make plastic bottles. This can be used to produce a hard product by injecting air into some reversible resin. This method can create reusable rigid products rapidly, but a mold is necessary when making an object using blow molding. Inflatable structure is made with soft material, which is differ from the blow molding. But this inflatable structure, such as temporary buildings and portable kayaks, are widely used because these products have lightweight and portability. These products are decided on shape before inflating, and people doesn't need to make mold. Moreover, recently, several fabrication studies of shape-changing interfaces of HCI have proposed. These products are made of soft elastic materials, such as rubber, so it is necessary to continue to pump air to maintain their shape. And there is a risk of air escaping from a small hole. So we combine the blow molding technique and rapid digital fabrication to create hard inflatable products. This is one of the contributions for HCI and the digital fabrication field. Second contribution is auto bending techniques by creating patterns on the seat before injecting air. Third contribution is designing software for simulating the modification of final shape. Next, I will talk about whole creating process with BlowFab. First step, the laser cutter cuts multi-layer sheet consists of the layer of masking tape and some plastic. Next, the user bond two fabricated sheets together to arrange an airbag inside the seat. In this method, the user only has to stack two sheets and heat them with a heater because the softened materials fuse automatically with each other. Last step, the user pumps the object with an air compressor to infuse air in the seat. The plastic sheets of material consists of 3 layers stacked with carton film, PET plastic sheet, and masking tape. The carton film is a heat resistance film. The user cut and engrave this plastic sheet with laser cutter. And usually the object inflate like left side. laser cut the scrape of the masking tape of the bonding area. After the user stack 2 seeds and heat them, the scraped area fused and adhere, and the remaining area cannot be bonded in the masking tape area. So, but our techniques can not only inflate 3D objects, but also create texture on the surface. One is making a dent on the surface. This method can texturize an uneven surface by scraping masking tape in the center, like right side. One more method, the Kapton film is used for generating an uneven texture on plastic surface. The heat resistance temperature of a Kapton film is different from a PET plate. By remaining the temperature of the softening point of PET, the Kapton film cannot stretch. So the heated area without Kapton film is elastic, and uneven texture can be generated. After this, Kapton film can be removed, and the user can change the shape with different pattern. The user stacks the 2 cut plates and heats the seat with a heater or a heat gun to soften them. The heating time change depend on the heating temperature. When the thickness of the PET sheet is 1 millimeter, the heating temperature is 120 degrees Celsius, and the heating time is about 3 minutes. When the heating temperature is about 400 degrees Celsius, and the heating time is about 1 minute. After heating the plastic sheet, the object can be inflated automatically using the air compressor or manually using a straw. And so we developed several inflating techniques. In contrast to inflatable objects, use rubber, BlowFab can make hole in the inflated surface of hard material. So the user engraves only the PET layer. After inflating object, the user can make a hole by peeling off the masking tape. This is a base which is created using these techniques. Basically, our method creates liner objects, but the user creates complicated shape by combining multiple objects. They can be stacked because object has a bulge on the top surface and the hole on the bottom surface. These blocks made by applying these techniques. And we develop advanced techniques for bending object in any direction by inflating the seat and by designing bending pattern. The user can bend the seat in the vertical direction and in horizontal direction. Using these techniques, the flat shape can be transformed into a complex shape like this lizard shaped object. In horizontal bending mechanism, it is necessary to make a cut in the side of the seat to bend the object horizontally. We investigated the curvature by changing the parameter. For example, object EFG and length of AC and D was fixed, and the number of incision was 6. The object were inflated by changing the ratio will be the range of 440, 14, and 27 millimeter. As a result, the average angle was changed from about 522 and 38 degree. When we change the number of incision to 12, the object bent about 70 degree, like object H. Based on the result from this experiment, we developed the software that automatically designs shapes at the specified angle. When creating large objects, the laser cutter has a limitation of the cuttable size. By creating a 19-degree bendable shape, the user can create shapes larger than the machine range. This 110 centimeter long object was created from 60 centimeter square sheets. In the vertical bending mechanism, the user can bend an object automatically in vertical direction by overlapping material that has different softening points. The softening point of polycarbonate is from 120 to 140 degrees Celsius. When the sheet is heated to the temperature less than 120 degrees Celsius, only the PET layer becomes soft. When the user injects air, the object bends because the hard polycarbonate plate. For this method, polycarbonate plates are placed like this black area, and the user makes pattern on the polycarbonate using a laser cutter. The curvature of object was examined by changing the distance between two polycarbonates. The size of object and airbox is fixed. When the distance between two polycarbonates was changed from 0 to 30 millimeter, the average angle changed from about 100 to 140 degrees. Based on this result, we also developed the simulation software like horizontal bending. Because this method can create a hard product, the user can create furniture such as a chair. Large products such as furniture have an advantage of portability and reusability. However, it is difficult to heat entire surface uniformly. In current system, the user can make large object by creating airbag, which is the same size as a heater, and inflating them one by one. The user can also create other furniture like desk using the horizontal bending mechanism. In the additional application, the user can add a function such as touch sensor to a shaped object by attaching electric circuits using a conductive tape. Before engraving the surface with a laser cutter, the system can print picture on the surface with an inkjet printer. So we discussed the accuracy of the shape objects created using this method. The laser cutter has a high precision in horizontal direction, but the resolution in the vertical direction is low. So the current system can only express the texture. But the tools can be used to create a complicated object by stacking multiple block-shaped objects. Or we can combine BlowFab with other digital fabrication methods such as a 3D printer to create a mold. And the strength of the finished object can be increased by changing the thickness. We made object with thickness of 1 millimeter and 2 millimeter. We measured the strength of each object using a breaking point measuring. As a result, the pressure force on 1 millimeter is about 1,200 Newton, and the force on 2 millimeter is about 2,500 Newton. So we conducted an experiment to investigate how many times the object can be reused. When the heating temperature was 120 degrees Celsius, the object can be reused 20 times. But when the heating temperature was about 150 degrees Celsius, the shape becomes enlarged and rings appear on the surface. So we propose BlowFab, which is a method of fabricating high-speed, reusable, and storm 3D objects using blow molding and laser cutting. So the limitation of current system is that the user cannot heat a whole object simultaneously. In the future, we plan to print heater on the surface with a flexible conductive ink. And for creating the huge structure, such as a building, we have to consider a strong design, such as a truss structure. So in recent year, due to disaster, temporary house are needed all over the world, so people can carry a larger amount of fabricated boards with this method and construct easily on site. It is also expected to use in space development, such as inflating moon base after transporting in the moon. So there are many problems, but we plan to resolve them. So thank you for listening. So project member is me and Ryuma and Yasuaki. And I'd like to thank you, JSC Erato Kawahara project for supporting our project. Thank you so much.
Great talk. I was also curious how to add interactivity to those objects. You mentioned a bit you want to print the conductive ink, somewhere in the process. How do you envision this? Do you pre-print the circuit layout and you stack it into your layer stack, or do you want to etch something away, or how do you imagine this working out?
So you mean how to create your
yeah,
circuit?
this one, yeah.
Yeah, so currently I'm thinking before engraving with laser cutter, you print the conductive ink whole surface, and you engrave the only conductive ink layer, so you can make a circuit of heat.
Okay, thanks.
Hi, Sean Fulmer, Stanford University. Nice project. I'm wondering if, so in traditional blow molding, you have the external mold often to constrain the maximum amount of inflation. And I'm wondering if you thought at all about ways that you could instrument your system by temperature sensing or infrared camera view, as well as like pressure sensing to sort of have a closed loop in terms of how much inflation you get and what the desired ultimate shape would be?
Yeah, that is good point. And so, yeah, so in current system, there for example, air compressor continue to pump the air continuously, but so next step, I want to control the air pressure by monitoring the computer. And so in that situation, so you can change the length, thickness of the product. So yeah, that is next plan for our projects. Yes.
Okay.
Thank you.
Hi, Michael Rivera, Carnegie Mellon University. So I think this is really cool, and So I have one clarification question, which is when you're inflating the softened plastic, is the air you're using already hot, or are you just inflating it while the plastic is just soft? So in theory, if the air is not hot, you'd be cooling the object as you're inflating it, right?
So you mean the
So the air you're using to actually inflate,
yeah,
right? That air is not hot.
not hot.
Not
And
hot,
so
okay.
yes, the inflating process is has a inflate object and cooling
Okay.
the surface.
So then, in theory, you're limiting the ability of that to expand, right?
Yeah.
Okay. And then, so the next question would be, have you looked at sort of like failure and strain? Like, what's the maximum strain you can get out of your objects as they're inflating?
Sorry,
So when you're inflating it, have you looked at the maximum amount you can inflate the object before you reach failure, or the plastic essentially starting to degrade and break?
It depends on the temperature, but about 100 degrees Celsius, the surface is gonna be stopped when reach the maximum shape, and the air leak from the side of a nozzle of air compressor, so not break. But when you hit high temperature, maybe the surface is gonna be break or make holes. Yeah.